Alright, so for Chapter 2, we're going to cover data warehousing. I'm only going to cover part of the chapter today. I'll post the other half of the video lecture later on. Today we're going to cover up until slide 14. And the first thing you'll need to know if you go along with your study guide is what is a data warehouse. A data warehouse is basically a physical storage of data. Data is organized and cleansed and stored in a standard format. Basically, it's stored to provide for analysis and support decision support functions. So basically, decision support systems allow for analysis of patterns. So they help support decisions. And so not only does the data warehouse, not only is it designed to help with analysis, but also decision support. Okay, so characteristics of a data warehouse. They're subject-oriented. They only contain information relative for decision support. They provide a comprehensive view of the organization. And then integrated means that they're evenly formatted, so data taken from all different areas is formatted to be consistent. And then there's a time variant, meaning they allow for different time points, like daily, weekly, monthly. It has to be able to accommodate all those points. Now, another characteristic is that they're non-volatile, meaning data entered cannot be changed. You can make it obsolete and then update it with new information, but you can't actually change information once you put it in the database. They're typically designed to support web applications because a lot of analysis now is done through the internet using software from location. You know, you don't go to the database anymore and plug your computer in. That's basically what that means. And then I'll go over relational and multidimensional, the next slide. And then it's client-server based, meaning you log onto a client PC to access the server. Like I said before, you don't go and plug your computer into the database. Okay. I gave you a link to a technical comparison of relational and multidimensional databases. It's actually a really good link. And I think I actually you have to start the slides to be able to see it. Yeah, you control click the link. And you'll see it compares dimensional and relational databases. Relational is usually 2D, it involves tables, and then dimensional usually involves like a cube analysis. And we'll go over that some more as we go on. But you may want to review this if you want a better understanding of the difference between the two. Okay, so let's go back to the slide. All right, so a relational database is one that uses 2 dimensions, just tables, and they're usually linked by common values. So like when you go into Access and you link tables, that's usually a relational database. Multi-dimensional databases, they're optimized for data warehouses and online analytical processing systems. They're often created using input from existing relational databases. So they'll use the relational databases. They allow you to ask questions rather than having to query the database using a programming language, which is useful to users who may not understand the programming language. So it creates a more usable system that can be accessed by almost anyone. Okay, and another characteristic is that it's real time and right on time, or right time, sorry. Newer data warehouses, they provide real-time data. Some industries require real-time information. We'll get into that a little more in later slides. But just know the older data warehouses didn't have real-time information. They had historical information. So your newer databases are going to have your real-time information. And your metadata, technically, in a technical sense, it's data that tells you about, it is data that tells you about the data, but technical users tend to see it more as it describes maybe the user that used that updated the information, made changes. In terms of a business sense, it also tells you information about the data itself, like formatting, how it should be used, things like that. And we'll cover it more later on as well. All right, so a data mart, it's a departmental data warehouse. So usually your data warehouse is made up of data marts. They usually have information pertaining to a specific department. So you have two different types of data marts. You have a dependent data mart and an independent data mart. Dependent data marts, they're created directly from the data warehouse. Independent data marts, they're designed specifically for a strategic business unit. All right, sorry about that. My escape key wouldn't work. What I wanted to show you was I do have some more information down here. So a dependent data mart, it provides quality data, but it's high cost. An independent data mart is lower cost, and it's a scaled down version of the data warehouse. Okay, so definitions about parts of the data warehouse. An operational data store is a type of database used for interim storage. So basically data is stored there. Yeah, you can see it's stored there. Unlike the static contents of a data warehouse, the contents are updated throughout the course of business operation. And then it's used for short-term decisions. And it stores only recent information. So it's kind of like an interim area before it's actually brought into the data warehouse. I think, yeah, the Oprah stores, or Oprah Mart, sorry. It's an operational data mart. And it's created when the operational data needs to be analyzed multidimensionally. You'll just need to know the definition of that term. Now, an enterprise data warehouse, it's a large-scale data warehouse. It's used for enterprise decision support. So you have to integrate data from many sources, and it has to be a standard format. And then it provides data from many types of decision support systems. You have customer relationship management, supply chain management, business performance management, business activity monitoring, product lifecycle management. And they can be very expensive to implement, and so they need to be designed and implemented correctly. And then, like I said before, I'll go over metadata again. So it describes the structure of and some meaning about data, and it contributes to the effective or ineffective use of that data. There's three types of metadata. You have syntactic, which it describes the syntax of the data. You have structural, which describes the structure of the data, how it should be structured, and how it is structured. And then semantic metadata describes the meaning of the data in a specific domain. And then I mentioned again that usually review data, metadata is something that can give us information about authors and changes made to the data. But it can also tell us more about the data itself. So those are some terms involving data warehouses that you'll need to understand. And now we're going to go into the actual framework of the database, well, the data warehouse. So as you can see here, there's data sources, and we'll go into this in more detail as we go on. But basically through the extraction, transform, and load process, the data is basically processed and added to the actual enterprise data warehouse. And then these are your data marts. And they're accessed through middleware, which your applications access, this is how your end user accesses the data warehouse. And we'll see that as we go through the process. So first, you're going to have your data sources. So you have multiple independent legacy systems, different types of formatting on the data. It can come from OLTP systems or ERP systems like SAP. The data is extracted from those systems and transformed using commercial software called Extract, Transform, and Load. And you'll learn more about that later on. And then it's loaded into a staging area where, again, it's transformed, cleansed, and then loaded in the data warehouse. So basically, you grab your data, you transform it, make sure it's all got the same formatting, and then you finally put it in the data warehouse. So you're going to want to make sure the data meets the requirements of the system before it's added to the system. And usually you have a software program that does that. All right. And then all of that goes into the enterprise data warehouse. And I think I summarized that down here. Yeah, the data is broken into data marts based on the type of data needed and is accessed using middleware tools. So metadata, it tells you about the data, and then your middleware tools are your access tools. And it says here you can either write SQL queries to access the data warehouse, or you can use software programs such as Business Objects, which is an SAP software. And I think I will cover the transformation process today since we did just talk about it. The data integration and the extraction, transformation, and load process. So data integration comprises 3 processes: access, federation, and capture. So data access views the integration of business views across multiple data stores. Or data federation is the integration of business views across multiple data stores. Those shouldn't be the same. Hold on 1 second. I may have had a typo there, because those should not be the same. Okay. Let me pause this real quick while I find it. Okay, so data access is actually the ability to access and extract data from any data source. And data federation is the integration of business views across multiple data stores. So this one is wrong. I'll fix that. And then change capture is based on identification, capture, and delivery of changes made to the enterprise data source. And so that leads you to 2 types of integration. You have enterprise application integration and enterprise information integration. And then are just vehicles for pushing data into the data warehouse. And then the information integration has to do with real-time data integration. And this shows the ETL process. Extraction is where you read data from one or more databases. Transformation is where you convert the extracted data into a form which it needs to be in the system. And load is where you load it into the data warehouse. And then there's some issues that affect the purchase of ETL tools. They're expensive, and it has a long learning curve. You know, it is a pretty technical tool. And in order for it to be useful, it needs to be able to write an unlimited number of data sources. It needs to have automatic capturing and delivery of metadata. A history of conforming to open standards and easy to use interface. So that kind of will cut down on the learning curve. And that's where we'll stop for this video. On the next video, I will start with slide 18 and go over data warehouse development.